Hello, physicists. My name is Gavin Baker. Today, I'll be analyzing the motion of a performer using Newton's laws of motion. So, I use Tracker to track the motion and GlowScript to create a computational model to predict motion. First, I'll go over the results and explain what concepts support the observations. Later, I'll be comparing the data and explaining any discrepancies. This experiment is relevant because creating a computational graph that can simulate motion can help explain the seemingly impossible trampoline jump. Here is the software I use to determine the observed data. So, I track the position of the origin of each frame to attain this data. The average height of a man is about 5'7", so that's how I measured the height. The man moves up and down and bounces elastically to where he started. For tracking the observed motion, I set the origin of the man's center on the first frame, and that is also where I place the axis. Here is the code I use to produce the predicted data. Using the observed data, I calculate the initial velocity from the first two frames when he starts to fall. The time step is 1/30th of a second to match the observed time step. And down here are the different energies involved with the problem. I also included elastic collision. Both the tracker data and the computational model display a wave-like curve in the y direction as time passes. This makes sense because the trampoline bounces the performer back up. The beginning is after he jumps 1 meter up off the platform. This is an elastic collision with a static trampoline. There is some loss of thermal energy when the collision happens. The potential energy was converted into kinetic energy to bounce him back up to the platform. It seems weird that he manages to make it all the way back up against gravity, friction, and thermal energy lost by hitting the trampoline. The observed and predicted motion from the computational model are very similar. The general shapes are very close. The GlowScript model is a little more curvy and does not go as much down. A few reasons could explain this. Perhaps some of the calculations in the coding was not precise enough. Multiple tests and more accurate data collection would help in future experiments. For this example, there is kinetic, gravitational, and thermal energy involved. The potential energy is converted to kinetic energy right before hitting the trampoline, and some of the energy is lost by colliding with the trampoline as thermal energy. And here are the various equations used to calculate each energy. So how did he manage to get back to the top after the bounce? He is very clever. He knows that he needs to maximize his energy at the top and minimize his energy loss while falling. To increase his potential energy, he jumps 1 meter up to increase his height and therefore his potential energy. He lands on the trampoline with his back to evenly spread his entire max to maximize his bounce. Overall, these tricks help him reach the top. And thanks for watching.